Very good morning to everyone. Today we are going to discuss one of the important converter known as cycloconverter. Outcomes. At the end of this session, students can able to explain what is cycloconverter, list the types of cycloconverter, basic principle of operation of cycloconverter, and finally list the applications of cycloconverter. Let us discuss types of cycloconverter. Before going to discuss types of cycloconverter, first understand what are the types of converters available in power electronics. There are four types of converter. First one is AC to DC converters called rectifier. Second one is DC to DC converter is also known as chopper. And third one is DC to AC converter, it is called inverter. And final one is AC to AC converter. This is called AC to AC converter itself. Now, in AC to AC converters, we can vary two parameters. One is voltage, another one is frequency. If my input side is fixed voltage and fixed frequency, and my output side is variable voltage and fixed frequency, that converter is known as AC voltage regulator. What is cycloconverter? In cycloconverter, the input side we have fixed voltage and fixed frequency. In the output side it is become variable voltage and variable frequency. So that type of AC to AC converter is generally known as cycloconverters. So it is simply called frequency converter. Fixed frequency to variable frequency. Types of cycloconverter. According to output frequency, it can be called step up and step down. According to the supply voltage, it may be a single phase to single phase, three phase to single phase, and three phase to three phase. Applications of cycloconverters. Generally, it can be used in speed control. How speed can be controlled? The synchronous speed of the machine is defined by 120 F by P, where F is the line voltage frequency in hertz, P is the number of poles, and the N is the synchronous speed in RPM. So, in order to vary the synchronous speed, we have to vary the frequency. The synchronous speed is directly proportional to frequency. So by changing the frequency, we can change the synchronous speed. By changing the synchronous speed can be used in many speed changing applications such as grinding mills, rolling mills, cement mills drives, heavy washing machines, aircraft power supply, ship propulsion drives, synchronous motors, water pumps, industries, any kind of industry which required speed variations, and induction heating. The basic principle of step-down cycloconverter. Let us assume that our input frequency having 60 Hz, and this is the positive off cycle and this is the negative off cycle. So we have a one positive, one negative, one positive, one negative. So when we converted into step-down cycloconverter, the output for the three first off cycle is converted to a positive direction, that is a positive off cycle, and all next three cycles are converted into negative off cycles. So now these three positive off cycle act as one half of the positive cycle, and these three negative off cycles act as another half of your negative cycles. So this is the six cycles now become one cycle. So this is not a six cycle, this is the six pulse, but actually a 3 cycle. This 3 cycle is become 1 cycle. So the red line shows it's a 1 cycle. So the 60 Hz frequency is now converted to 20 Hz frequency. So we are now stepping down the frequency. Variable voltage and variable frequency cycloconverter. In this case, we can also vary the voltage as well as frequency. Here we are using a thyristor to vary our voltage, and this is not from starting from 0, and C, it is starting from some firing angle alpha. So by varying alpha, we can vary the frequency as well as the magnitude of the voltage. This is the step down cycloconverter diagram, and here we have two back-to-back connector thyristors for a positive off cycle, and again we have a two back-to-back connector thyristor for negative off cycle. So as we discussed earlier, this is a basic principle of operations of a step-down cycloconverter. In step-up cycloconverter, again the diagram remains same, but in this case the one off cycle is divided into, see here, 1, 2, 3, 4. So the one off cycle is divided into 4 off cycle. That means, so this is the 1 Hz, this is again second Hz. The 1 Hz, the one off cycle is converted into 4 off cycle. That means it is a 4 times, the frequency is 4 times greater than the input frequency. And here I am like to show you step up and step down bridge type cycloconverter. So earlier we have seen, and this is the center tapped transformer based, and this diagram is bridge converter based, and this is 3-phase to single phase cycloconverter diagram. I'm just like to show you the diagram. I'm not going to explain how it is working. And this is the output waveform of 3-phase to single phase cycloconverter. This is the enlarged version of the same 3-phase to 3-phase cycloconverter. And this is again 3-phase to 3-phase cycloconverter in full view. And this is a single module. And this is the here we are not showing all the thyristors. We are grouping all the thyristors, and here we shown all the thyristors. Cycloconverter. The cycloconverter is a single stage frequency converter used for variable speed applications. And by answering all these questions, you can understand the cycloconverter even better. Cycloconverter is basically, there are 4 options: AC to DC converter, DC to DC converter, DC to AC converter, AC to AC converter, and the answer is AC to AC converter. Output of cycloconverter is variable voltage only, variable frequency only, variable voltage and frequency, none of the above. The answer is option 3, variable voltage and frequency. Cycloconverter is used to step up the frequency, step down the frequency, step up and step down the frequency, step up and step down the voltage. And in this case, step up and step down the frequency is correct options. Step up and step down the voltage, actually it is also right option, but the cycloconverter is used for step up and step down the frequency, not for step up and stepping down the voltage. In cycloconverter, forced combination is required for step up, step down. Both step up and step down not required. So it is required only for step up, not for step down. Cycloconverter is used in variable speed applications in induction motors, induction heating, variable speed application in synchronous motors, all of the above. The right answer is all of the above. Thank you.